Have you ever thought about what keeps your online life safe? Your bank details, your private messages, all of it is protected by a digital lock called encryption. But what if I told you there is a key being built right now that could unlock everything? And no, this isn't a scene from a sci-fi movie. This is the real-world threat of quantum computing. So let's dive into how today's encryption actually works. Imagine you have a secret message. To protect it, you lock it in a box using a special number. This number is created by multiplying two incredibly large prime numbers together. To unlock the box, you need to know those original two primes. This is the foundation of many encryption systems, like RSA, which is used all over the internet. Now, for a regular computer, figuring out those two original primes from the bit number they create is an almost impossible task. We're talking about numbers with hundreds of digits. A classical computer would have to try zillions of combinations, one by one. It could take thousands, even millions of years to crack just one of these codes. That's why your data is secure. The math problem is just too hard for our current technology to solve in any reasonable amount of time. It's like trying to find a single grain of sand on all the beaches in the world. It's technically possible, but practically, it's not going to happen. This is where quantum computers change the game entirely. They aren't just faster versions of the computers we have today. They think in a completely different way. Your laptop or phone uses bits, which are like light switches. They can either be on or off, a 1 or a 0. Quantum computers, on the other hand, use something called qubits. A qubit is a bit of a show-off. Thanks to a wild principle of quantum mechanics called superposition, a qubit can be a 1, a 0, or both at the same time. Think about it this way. A classical computer is like walking through a maze, trying one path, hitting a dead end, backing up, and trying another. It's a slow, step-by-step process. A quantum computer, with its qubits in superposition, can explore every single path in the maze all at once. This ability to perform many calculations simultaneously gives it an incredible advantage for certain types of problems. And unfortunately for our digital security, one of those problems is factoring large numbers. This brings us to the key that could unlock our digital world, Shor's algorithm. Back in 1994, a mathematician named Peter Shor developed an algorithm specifically for quantum computers. Its purpose? To find the prime factors of a large number incredibly fast. While a classical computer would need eons to break a strong RSA key, a sufficiently powerful quantum computer running Shor's algorithm could theoretically do it in a matter of hours, or maybe even seconds. Imagine the implications. Every encrypted email you've ever sent, the password to your bank account, government secrets, health records, all of it could be exposed. Any data that is encrypted today could be harvested by an adversary, stored, and then decrypted later once a powerful quantum computer is built. This is often called a harvest now, decrypt later attack, and it's a major concern for intelligence agencies and large corporations worldwide. The digital locks we've relied on for decades would simply melt away. So how close are we to this quantum apocalypse? Well, don't panic and delete your bank apps just yet. Building a quantum computer large and stable enough to break modern encryption is a massive engineering challenge. The qubits we have today are very delicate. They're easily disturbed by tiny changes in temperature or vibration, which can cause errors in their calculations. We're still in the early days of this technology, kind of like where classical computers were in the 1950s. However, the progress is happening fast. Companies like Google, IBM, and many startups are in a fierce race to scale up their quantum machines. They're improving the number of qubits, and just as importantly, the quality of those qubits. While we might be a decade or more away from a machine that can threaten our current encryption standards, the threat is no longer purely theoretical. It's on the horizon. Because of this looming threat, the world's brightest minds in cryptography are not just sitting around waiting for the inevitable. They're already building the next generation of digital locks. This new field is called post-quantum cryptography, or PQC. The goal is to create new encryption algorithms that are secure against attacks. from both classical and quantum computers. Instead of relying on the difficulty of factoring large numbers, these new methods use different, much harder mathematical problems. For example, some are based on something called lattice-based cryptography. Imagine a vast multi-dimensional grid of points. The problem is to find the closest point in that grid to a random point you've chosen. It sounds simple, but as you add more dimensions, it becomes incredibly complex, even for a quantum computer. Other PQC approaches use hash-based cryptography, code-based cryptography, and other mind-bending math concepts. The race is on not just to invent these new algorithms, but to standardize and deploy them. The U.S. National Institute of Standards and Technology, or NIST, has been running a global competition for years to select the best PQC algorithms that will become the new standard for protecting data. This is a huge undertaking. It means upgrading virtually every piece of software and hardware that uses encryption, from web servers and phones to cars and satellites. So, what does this all mean for us? The threat isn't here today, but the preparations for it are well underway. Quantum computing is a double-edged sword. It promises to revolutionize fields like medicine, material science, and artificial intelligence by solving problems we can't even dream of tackling today. But it also forces us to completely rethink and rebuild our digital security infrastructure from the ground up. It's a fascinating and critical moment in the history of technology. We are witnessing the beginning of a massive transition, a global upgrade to our digital defenses to stay one step ahead in this high-stakes race between code makers and code breakers. The quantum era is coming, and it will change everything. What do you think is the biggest challenge in this quantum transition? Or what other emerging tech threats should we explore next? Let me know in the comments below. Thanks for watching, and if you found this interesting, don't forget to like and subscribe for more deep dives into the future of technology.